Hi. In this video I'm going to show you a few things that you can do with Filter 8 by Joranalogue Audio Design. Filter 8 is a great filter. Not only does it have 8 outputs that you can get different flavors of sound out of, it also has a multitude of modulation inputs, a hold input, and a dedicated ping input that you can use to ping the filter with. And of course, when you crank up the resonance, you can get filter 8 to self-oscillate. And then by just using the volt per octave input here, you can use it as a VCO. None of those things is what this video is about. DivKit already did an excellent job at explaining how this filter works. He did all the filter sweeps and used all the modulation inputs to create interesting feedback patches. What I want to do is show you a few, I think 7 patch examples of things that you can do with Filter 8 that you might not have thought about yet. I'll play these patch examples first, and then I'll walk you through a few more things that I think are interesting to explain about Filter 8. And once again, I want to thank Joranalogue Audio Design for supporting my work on this video. Let's have a look at the patch examples and I'll see you on the other side. I think after watching those patch examples, you already should have an idea of how you can use Filter 8 in different ways. But there's still some things I want to explain in a little bit more detail. One thing that you saw me doing in the patch examples quite a lot was routing feedback from one of the outputs of Filter 8 back to its exponential FM input. And when Filter 8 is self-oscillating, this creates different shapes than just the sine wave. Let me patch up the output to data here. Now let's just listen to it at audio rates, but you can get the same results at LFO rates, just a little bit slower, of course. So this is just the sine output from the one-pole low-pass filter with the resonance turned up, so Filter 8 self-oscillates. We can listen to this if my cable is long enough. Let's tune it down a little bit so it's a little less annoying. So there you can see the sine wave. I just want to show you what these different outputs do and how they affect the shape. So when I now connect the two-pole low-pass output to the exponential FM input, you can see that the shape is changed drastically. Now by increasing the FM index, the wave shape changes more, but it also affects the frequency of the oscillations, as you can hear. We can also turn this knob to the left, which kind of does the opposite of what we saw when we turned it to the right. Now when we take another output, let's just go for the three-pole low pass here. You can see that the effect is a little bit different. Let me turn it to the left. And let's just quickly go through all of them. This is the four-pole low pass. Now the one-pole high pass. Maybe I should zoom out a little bit. There. Now the notch output. You can see that all these different outputs, when you connect them to the FM inputs, they all make the wave shape behave a little bit different. Let's try the, yeah, what is this? The phase output. You can see that this one almost makes a perfect saw or inverse saw wave. And then we have the 4-pole bandpass output as well. Now, of course, if you like this sound but you want it pitched up higher, then you just retune your VCO to whatever note you want. And of course, in this mode, filter 8 still tracks 1 volt per octave. But of course, from the moment that you start turning the FM index knob again, the pitch also changes. So it's best to set this and then keep your hands far away from it if you're doing an important recording. Now, of course, we just monitored the 1-pole low-pass output. But when you start monitoring different wave shapes at the same time, and then you add feedback to them, you'll see that the waves are always a little bit different. So let's listen to the green one to the left, and let's listen to the blue trace here. Now I'm just gonna patch up some feedback. Something I also wanted to tell you is that right now you can see that these oscillations are a little bit less in amplitude, and this is because all the outputs have a little bit different character, and the amplitudes of the different outputs might be different as well. To compensate this, there's a really useful comp switch here which compensates for this amplitude loss, and as with other Joranalogue Audio Design modules, you engage a function when you put the switch in the down position. Now, just a little warning, this will get a lot louder suddenly. 3, 2, 1. Now all the outputs should have somewhat the same amplitude. So this is really something interesting that you can play around with. Something else that I wanted to show you, which you can also do in LFO mode, but it's easier to see and hear what's happening at audio rates. When you patch an audio rate signal coming from, I'm just using a sine from a generate that's just off screen here. When you patch this to the hold input, then you need, of course, to engage this circuit by switching this switch in the down position. You can see on the scope, at least when I move this cable, you can see that the filter core is held whenever there's a signal at the hold input present, but because this signal is now at audio rates, you get, yeah, I don't know how to call this, but you get this interesting effect. Let me turn up the oscillator that I'm using to modulate this hold circuit. I'm curious how this sounds with a sequence going into filter 8. Maybe I should mold this sequence to the VCO I'm using for the whole circuit here. And as you can see, this gets really interesting. And again, you can do this at LFO rates as well. One more thing that I wanted to show you in more detail is how this ping input behaves when you're using it at low frequencies. So first of all, to get anything moving, you need to switch this switch for the whole circuit back in the up position, or else nothing's happening, everything is stalled. So to get filter 8 self-oscillating, you need to turn up the resonance. And the point that it starts self-oscillating is a lot higher when you're using a low frequency. Look what happens when I turn up the coarse knob here. You can see it starts feedbacking and oscillating. And this is something that you should keep in mind when you're pinging the filter as well. You'll see once it's oscillating and I turn down the coarse knob, it will keep oscillating even at lower frequencies. But this also affects the behavior of the filter when you are using the ping input. So sometimes it takes some time to get the resonance setting just right, so it reacts to the ping signal that you are sending in. Now, this ping input just creates the perfect envelope for the filter to resonate, and this ping input really reacts to just about anything that you send in, triggers, gates. But let me first turn up the frequency and adjust the resonance so it's just on the edge of self-oscillating. And then we can start to see what the effect of the pinging is. Now, it's probably very clear, but we're not getting the same amplitudes as when we would just crank up the resonance completely. And this, of course, affects the usability of these signals for modulation. It's just something that you need to keep in mind. So I have here an output from Generate 3. I've routed it through Angle Grinder, which is just behaving as a filter right now. And let's connect the pinged LFO from filter 8 to the... I'm just going to use the volt per octave input, because this is essentially just an exponential FM input. And you can see we're not getting the same amplitudes as we got before, but let's turn up the coarse knob on filter 8, which increases the speed of the LFO. But this also gives us amplitudes that are a little bit higher. I think this is a really interesting feature of filter 8, that you're able to just ping this filter when it's self-oscillating at low frequencies. In my experience, not every filter has the ability to go sub-audio rates. Normally, the range of the cutoff knob isn't adequate to get there, but sometimes it's possible when you just send in a negative CV signal into the FM input. But even then, most filters that I've tried this on just won't go lower than audio rates. The one filter that I was able to pull it off on was a Ripples clone. And it's by turning it to sub-audio rates that you can use it as an LFO and as a slew limiter. And that's something that I also still wanted to show you in a bit more detail. So perhaps let's just use this sequence that I had running here. I'll patch it into data, and now when I send this signal, which is just going through data, into filter 8, I'm just randomly selecting an output. They all behave a little bit different, but I think that's something that you need to experiment with. So I'll just turn up the frequency completely and just switch this to audio rates for the moment. Let's put this at the same sensitivity. There it is. And now I'm just going to connect the output, so this blue cable, which is the sequence going through filter 8, and I'll connect this to the Volproductive input on Generate 3. Let's give it some character with the ankle grinder. So the sequence that's going through filter 8 is just coming out the same as it went in, because there's no filtering or slew going on. So just by changing the resonance, you affect the signal somewhat. So let's turn this down. And now you'll see that even at audio rates, when I turn the coarse knob on filter 8 completely down, it will slew this sequence a little bit. And this is actually what I did in the patch example earlier. And as you saw, you can control this with voltage, because when you're sending in FM, you're essentially just automating the movement of the coarse knob. But now let's switch over to low rates on filter 8. So you can see that when the filter is completely open, even at the low setting, we don't have any slew, but you'll see from the moment that I start lowering the frequency here, we will be getting some slew. Now, of course, this isn't very musical, but I think this shows a little bit better how the slew on filter 8 behaves. So this will be it for this video about some unusual things that you can do with filter 8. I hope by recording this video that you can get somehow inspired to experiment with other things you can discover that you can do with filter 8. Maybe you can share this video with someone who is looking for a filter that can do a little bit more than just filtering sounds. If there's any questions or you just want to say hi, please just write a message in the comment section. I usually reply to these from the moment that I see them. And if you really like my content, you can also, if you wish, support my work. I have been using a Ko-fi page for a few months now, but I recently set up a Patreon as well, because I think some people are a little bit confused by the interface on Ko-fi, and perhaps Patreon is just a little more known to most people. The reason I went for a Ko-fi page in the first place was that it allows people to just donate a few dollars or euro once and then never come back, which is perfectly fine, it's great. The bottom line is, if you want to support me, now you have options. I hope you learned something by watching this video and you didn't get put off by all this talk about support. It's perfectly fine if you not support anything of what I do and just enjoy the content. For me, the most important thing is that you learn something from it. At least that's my goal. So thank you for watching. I hope you learned something. And I'll see you next time. Bye!